Welcome to Carbon Capture with Cattle with our presenter, Ridge Shinn. I'll introduce Ridge in just a moment, but just a few introductory remarks. We like to acknowledge that we are presenting, attending, and hosting this workshop from land that was managed and inhabited before European colonization. So you can visit this website on your own time, find out who may have lived on the land before you. And we like to encourage everyone to center racial equity in your own work. And there are a few examples of how NOFA Mass and other organizations that we work with are working on that. Some session etiquette. And we also like to acknowledge and thank our sponsors for allowing the conference to happen. Plenty of gold sponsors, and our silver sponsors can be found in our program book and also on our website. So make sure you give them a look and tell them you appreciate their support of NOFA. There's also an online auction happening all throughout the conference. Lots of good stuff donated from our supporters, and the money raised from that will go to support our education efforts throughout the Northeast. Also a virtual vendor marketplace that simulates the market that we have at our live conferences. So take a look around there, see if there's anything that you need or would like, and also thank them for their support. So I'll introduce our esteemed guest today. Ridge is the founder and CEO of a new 100% grass-fed beef company, Big Picture Beef, which markets beef raised in the Northeast on pasture only with no grain ever. So I'll let you take it away, Ridge.
Okay. Should I put my slides up or you do that?
You do that.
Okay. If I can find them. Okay, this looks like it.
Perfect. There you go.
Okay. Well, thanks for everybody for listening and joining up. This is basically, we're going to talk about carbon capture with cattle. By the time you get through hearing me, you'll realize that I think cattle can solve all problems, and everything's a nail and cattle can drive it. So anyway, but just to get started, let me give you a little background. So, uh-oh, no, it's not working.
Sometimes the arrows work, sometimes your mouse works.
Yeah. Okay, let me see. Let me see if we can set this up again here. Okay, there we're started. Okay, there we go. So anyway, just as a little further background, I tell people that I learned to farm in the 1800s because one of the places I learned to farm is at a museum in Massachusetts, Old Sturbridge Village. And Old Sturbridge Village, when I worked there, was trying to depict the period in central Massachusetts between 1790 and 1830. So what we did is we actually replicated the tools like the ox cart, the plow, the scythes, and then we tried to replicate the farmer's years. So we mowed the hay with a scythe when the farmers back then had mowed it, and we had the same number of cows and chickens and things like that. So that's where I got some of my education. That's actually me on top of the haystack. So you learn how to make hay with a scythe and make a haystack. But anyway, one of the things that was interesting about that time period, and it kind of refers to the introduction a little bit. So pre-European colonial settlement, obviously some other people lived here, but the land of Mass, for the most part, had mature trees here in the north. And one of the, we're going to be talking about carbon. So carbon is, carbon is good, say, or carbon's bad. Neither really. Carbon just is, and we use carbon. And really, the whole climate issue is what happens to carbon because of the way we use it. So pre-colonial, pre-European colonial settlement is like vast woods. By the 1830s, this is what the landscape looked like. And these pictures are from a diorama that's at Harvard Forest in Petersham, Mass. And you can go see this diorama. It's fascinating because they took the same piece of land and looked at it over time. So you have pre-colonial with all the forests and trees. This is by the 1830s, what the landscape looked like, that most of the landscape was open. Actually, by the 1830s, almost 80% of the land in the Northeast was cleared. Today, just to give you a kind of relationship, today, 80% of the land is in woods again. So in the 1830s, 80% was open. And so the question is, how did this happen? And, the settlers cut down the trees, but then what kept it cleared? And the answer is cattle. So a lot of people say, well, pigs cleared the land. Well, most people only had 1 or 2 pigs. Most people had 5 cows, a couple of oxen, a couple of young stock. So the cattle are what really cleared the land once the trees were cut down. And so anyway, this, as I said, the whole story of agriculture anywhere in the country is a story of evolution. So, pre-agriculture, then agriculture, then what happens beyond that. So the other story I like to talk about when we're talking about just in general, carbon and where it might have been originally. See, those trees in the pre-colonial are full of carbon. They're all cut down, and either burned or used for building or whatever. And but today a lot of them are grown back. But here's the other story. Everybody's heard about the buffalo, of course, and everybody's heard about the prairie. So at one time in this country, there are 60 million buffalo. So more buffalo than there are cattle in this country. And you had a very healthy environment. You had tall grass. Everybody's heard of the tall grass prairie. And everybody knows about the deep soils that are under the prairie, or were under the prairie, 8-foot deep soils. So I like to say to people, how do you think this happened? The deep soils, tall grass, 60 million buffalo. What was the prairie perfected, and then the 60 million buffalo parachuted into the prairie? Or were the buffalo wandering around on a dry lot and the prairie parachuted in? Well, of course, the answer is it was a symbiosis of the large ruminant paired with the plant and photosynthesis that actually created those deep soils. And that's kind of what, and it's really all about carbon. So it was the carbon is what made the deep soils, because the carbon capture from the air. So that's kind of what we're going to talk about is carbon as a problem, and then how we can get it out of the air and into the soil using large ruminants, which today are cattle, not buffalo. So here's a blast from the past. This is a carbon cycle chart that my son made years ago. He'd be embarrassed to see it, but the information is great. So if you look at the horizontal line is representing the soil. So you have things above the soil and things below the soil. What's fascinating is we're only beginning to discover all the stuff that's below the soil. Very recent discoveries. And we've been to the moon, we've done all kinds of things, but there's been very little research until recently about really what the heck's going on below the soil. But you can see over on the right-hand side of the picture, there's a factory and there's a car. And we all know that those industry and vehicles burn fossil fuels. So what's a fossil fuel? Again, we go back to the carbon. Fossil fuel is a plant that photosynthesized at some point in its life, that died and it was compressed, and now it's become a fossil fuel. So we mine that carbon from the ground, but originally it was a plant or a tree or something like that. But anyway, what happens in the process of combusting those fossil fuels is that it puts off carbon dioxide. So carbon dioxide is in the air, and many people feel like way too much carbon dioxide is in the air as a result of burning all these fossil fuels. Then you move over to the plants, and you can see a picture of this plant in the kind of to the left of the car, and you see a picture of the sun. So the sun is the real magic. It's a very simple system, photosynthesis. The plant needs CO2, which the air is full of, and takes the CO2 in and changes it into sugars and stores it below the soil. That's the real magic. That's the whole story, is that the plant will take the carbon in and make it into sugars and store it. Then what happens when you bring the bovine into the mix? Of course, the cow can eat the grass. It's one of the few entities that can eat the raw grass and make it into product that humans can use, meat and milk. We can't eat the grass that's generated by photosynthesis, but the bovine can. And what's interesting is in the process, the bovine is really fairly magical creature in that it's a ruminant. And what does that mean? It means that there's the bovine has a 4-part stomach. So essentially, how I describe a bovine is a mobile microbial vat. So if you've ever heard of composting, which I'm sure you all have, the rumen is essentially a compost pile. It works very similar to an anaerobic compost digester. But what's interesting is it's mobile. So you can actually, by your placement of fences, dictate where that microbial dump occurs. And that does happen. And that helps stimulate the soil food web, those microbes that come from the manure, urine of the bovine. But there's also, what's fascinating is as the bovine eats the grass, they actually use their tongue to grab the grass because they don't have the 2 sets of teeth. And as they grab the plant and shake it, that actually creates the root exudates leaving the plant, going into the soil. So it's all part of the magic of the carbon goes into the soil, feeds the microorganisms, which make which then break down the minerals and the plants. I mean, the minerals in the soil, which makes them bioavailable to the plant. So you get this kind of righteous cycle of the plant putting the carbon into the roots, the bovine extracting the biomass, putting back some, but actually helping in the carbon cycle. And of course, to the left, you have trees, which also are storing carbon in their roots. But anyway, to go from the simplistic schematic to look a little deeper at what's happening with the carbon cycle. This is just a prettier picture, but the same thing. You have atmospheric CO2, the plant using photosynthesis takes the CO2 out of the air and puts it into the ground and feeds the beneficial microbes, and the nutrients go into the soil with the interaction of the herbivore. So it's very interesting because there's all kinds of companies nowadays that are spending tremendous amount of research monies to try and figure out how to get carbon out of the air and then what to do with it. So they have these incredibly elaborate mechanistic schemes where they pump carbon out of the air and then try and pump it into the soil, below the soil. And it's just crazy making, because here's the system. It's been around forever. And one of the interesting things is that carbon is fairly volatile. Carbon wants to seek oxygen. It becomes CO2. So unless you store that product below the soil, not right at the soil surface, but deep, it will try and oxidize. That's just what carbon wants to do. So when you have photosynthesis working tall plants, then the roots are deep, and the carbon goes down into the roots. So that's a generality that we can make. If you look at the top of the plant, there is an equivalent depth of roots. So if you have 4-foot grass, you have 4-foot roots. If you're on a golf course and you have 3/4 inch grass, you only have 3/4 inch roots. And therefore, you have no resilience to drought. You have to feed the grass because there's nothing for it to grow on. And then you have to spray it with pesticides and herbicides. But when you have a healthy sward of grass in a field, you have an equivalent depth of roots. And so it's an important thing to remember, is that the CO2 that comes into the plant through photosynthesis gets stored way below the soil, so that it's not a totally anaerobic condition, but it's a much less volatile than carbon on the surface of the soil. So a whole piece of the puzzle that a lot of people don't know anything about is the fungi, the mycorrhizal fungi. And so the fungi hyphae will go, yards away from the plant, and they will communicate the nutrients back to the plant. And, they are the source of all these nutrients that the plant needs: phosphorus, nitrogen, calcium, and all the trace minerals and plant growing substances. So it behooves us to have a healthy soil where mycorrhizal fungi can be happy. And a lot of our agricultural land is like the picture on the left, where we have killed the fungi through our practices, mainly pesticides, herbicides, commercial fertilizers, big tractors, compaction, on and on. But a healthy soil, we want fungi. But see, it's hard because all these things are happening below the soil where we really can't see what's happening. But your typical agricultural practices of plowing, what happens is when you plow the soil, you allow the carbon to go up and become CO2. And happens fairly quickly. And so you have vast acreages of land that are plowed, and actually that old prairie that we're talking about in out west is mostly corn and soy now. So, actually 97 million acres, this statistic's a couple years old probably, but formerly grassland, prairie, that's been plowed and planted to corn. There's all kinds of political reasons, and that's not really what this talk is about. We could have a 3-hour chat about why that is, but corn and soy, corn is planted, and about 40% of the corn that's grown in this country, subsidized by our tax dollars, it goes to feeding cattle. Another 40% goes to ethanol, and the little bit that's left goes to making corn syrup, all of which are, my opinion, very detrimental to human health, not to mention the land and the environment. So what happens when you plow and you plant, you can see this soil is devoid of any plants other than the corn that's been planted. And that's because of the chemicals, pesticides, herbicides, glyphosate that's been sprayed. And what they've done is basically has killed the soil microbes, and very intentionally. I mean, a farmer growing corn would look at this corn and say, that's a beautiful field, nothing competing with the corn. And it is a beautiful field of corn, and only corn, a corn monoculture, no mice, no life other than the corn. And interestingly, once they spray the field and put down the glyphosate, then plant the corn, then they have to add the nutrients back in, which again, derived from fossil fuels, are negatively impact the soil food web that's below the soil and the carbon. Of course, this is where it ends up. I mean, this is a little detour from carbon, but we might as well talk about it, because this is 97% of the cattle in this country are fed this way. and here in a feedlot. And so, you know, the feedlot on the left, you can see all these pens and the cattle lined up at the feed trough. There's, you know, about 100 animals in a pen, and they stay here for at least 120 days in this pen. And the truck in the middle is a truck that's delivering the ration, which is predominantly corn and soy. And, you know, it's a very troubled system. It is the norm in this country, but there's all kinds of reasons that it's troubled. And if anybody's interested, we go back and spend a lot of, again, we can spend 3 hours talking about this, but this is a definition of the problem, not the solution. And so, you know, from this picture, I'm going to zoom out one more picture and show you what the feedlot looks like at scale. So on the left are these paddocks with 100 animals per paddock. Those are the driveways down the middle that the trucks bring the feed. And off to the right is, guess what? That's all the nutrients. That's all the result of that wonderful rumen compost pile that we talked about is ending up in what they call a lagoon. So all the nutrients are in this lagoon. And you don't need to know much about cattle or about anything to look at that and say, oh my God. But it's a real broken system. So because you have this corn land, which has been killed to grow the corn, and then you put the corn in a truck and you bring it to this feedlot, and then the nutrients that go through the cow are then deposited here where they can never get back to that cornfield because it's a logistical nightmare to move the nutrients back to the cornfield that's hundreds of miles away. So you end up with this, what they call a lagoon, a manure lagoon. And of course, there's many famous stories of when there's a flood or something like that, the lagoon breaks and it goes downstream and kills the Gulf of Mexico. So, you know, this is reality. So we're gonna move on to more positive because there is an answer. And the answer, of course, has to do with cattle, but cattle being raised a very different way. So what we are big proponents of is grazing using what's called adaptive multi-paddock grazing. So there have been many terms over the years. Some people call it rotational grazing, but the term that seems to be settling now is adaptive multi-paddock grazing. So in other words, you need a number of paddocks, you need movement and management of the whole system. But anyway, the goal is to try and recreate the way the buffalo were grazed. So you can see on the picture on the left, the buffalo, you know, lots and lots of buffalo in a group moving along, eating and moving. And of course, once this group of buffalo move through this particular patch of grass, the grass is trampled, it's covered with manure, urine, and there's nothing to eat. So they move on. And this grass then has a chance to rest and regrow, and then the buffalo come back. Now, certain parts of the West, that might only happen once a year. We are fortunate in the Northeast to have incredible rain, and we can rest the grass and come back to it pretty rapidly, 21 days sometimes, you know, or faster. But anyway, the idea is that we move the cattle, and depending on the class of cattle, we move them differently. So in other words, the cattle business or industry, and we'll talk more about as we go along, is kind of bifurcated into cow-calf and finishing. So currently what happens is cows and calves are born, they eat grass, calves are harvested off the mothers, and typically then sent to backgrounding in the feedlot. In our scenario, what we want to see is the cows and calves being harvested from their mother at about a year of age, and then moving to a grass finishing farm like the one on the right. But the idea is then that group of cattle get finished. But what's interesting is the two different classes of cattle have very different nutritional needs. So a cow with her calf. The cow is fully grown, typically, and therefore it doesn't need a lot of nutrition. She needs a maintenance ration, basically. And then the wonderful rumen and the way the cow is built makes the milk for the calf. And the calf grows up alongside its mother, nursing and eating some grass. And as the calf begins to grow, it needs a lot of protein because it's growing bone. It's growing its long bones. Well, once it gets to be about a year of age and has grown its long bones, then for it to get fat, it needs energy rather than protein. So a very quick way to describe the grass, everybody looks at grass and says, oh, there's grass. And everybody looks at a cow and says, oh, there's a mowing machine. But it really doesn't work like that. The grass is, there's different qualities in the grass. If you look at a stalk of grass in a field, the top third of the plant is typically got high amounts of energy. Then you have lignin, and then you have protein toward the bottom of the plant. So if you're looking to optimize the energy intake of the bovine, basically what you want to do is you want to move them so that they constantly have the top third of the grass to eat, or the top half of the grass to eat, and then move and then eat more, the top, and eat more. So when you're moving them like the group on the right, basically your management goal is to never let them eat that plant down to the ground where they're getting lots of protein, which they don't need. They really need energy. So you just keep them in constant motion, maybe 2 times a day, maybe 3 times a day. And if anybody's interested, you can see that wire is what's called a tumble wheel, and you can actually roll that wire. And you can see how the cows are all lined up right on the wire. They just got a new bite, and they're right there next to the wire when it moves because they want that energy. And interestingly, once you learn about the energy in the grass and the different needs of the cow calf and the finishing animal, and if you're very observant, when you put your cattle into a new paddock, you will see that they go around and they top all the plants. It's the first thing they do. They go around, they know where the ice cream is. They go and eat all the tops of the plants. Then they make another pass, they eat down. And if you leave them in long, then they're going to be eating sticks and roots. But it's really the human is the one that needs to manage that and give them the opportunity to get what they need. But the different classes of cattle need different qualities of grass. But what this does, this adaptive multi-paddock grazing does is build soil, stores carbon and water, and provides a remarkably clean protein for health, as well as has a positive impact on the rural economy. Anyway, let's dig in a little more how it all works. So this is a picture of another finishing farm, and you can see the grass is tall. This is an important point. And a lot of people, when you start grazing the grass in the spring, it's not very tall and it's real green. And the books in the university will tell you it's got high protein. Well, it does, but it doesn't have enough energy and it doesn't have enough lignin. So in reality, it's hard to manage, but you should let the grass grow because the rumen actually needs more than just protein. And one of the biggest mistakes you see a lot of people with cattle do is when you put your cattle out on the grass in the springtime for the first time, and the manure shoots out the back in a liquid form, you know those cattle have a tummy ache. They're miserable, and they certainly aren't gaining weight. They are just suffering. And so what you need to do is put some dry hay out there or manage your land so that there is some dry hay. They will go find what they need to keep that rumen functioning, but they need some dry matter, not just excellent, high protein grass. But, the whole idea is to manage them so they get what they need, depending on the class of cattle. So these cattle actually are fat, and you can see they're in deep grass, and that's the ideal. And to keep them moving, let them get what they need and then give them some more. This is just a close-up of that other picture, the same kind of idea. Grass is quite deep, you can see, and they'll eat here for 4 or 5 hours, and then they'll get moved to this new section. And that's how one finishes cattle efficiently. Now, we're supposed to be talking about carbon. So what's happening with the carbon? Well, when the grass is, when you have a big solar collector, guess what? You're capturing more CO2 and putting down more CO2. And whereas the real contrast to this field and that field of corn I was showing you is that there is no bare ground. There is no bare ground. You know, as Ray Archuleta says, nature abhors bare ground. And if you leave a piece of ground, immediately it'll grow up to weeds or something. It'll begin to get covered. It'll cover itself. It's kind of like a Band-Aid. So if your management has coverage on the soil, there's all kinds of benefits to the carbon being transported into the soil, health of the microbes, water, and on and on. We're going to get into that a little bit. One of the things that's hard for people to understand is how to transition to tall perennial grass, because a lot of farms have been worn out. I mean, around the country. You're talking about soils. When I say worn out soils, I mean soils that have had the carbon harvested from them. So potato land in Maine, tobacco land in the South, corn and soy in the Midwest. Many of these farming practices have been very extractive of the carbon. So how do you start? And one of the things that we have learned a lot about in the last probably 10 years is cover crops. So you can actually plant a crop into really kind of compromised land. And a cocktail cover crop, meaning a variety of species, they're typically annuals, so things that will grow quickly, make your solar collector right away, and will have varying heights and varying nutrient qualities for the cattle. The cattle just will absolutely eat it up, make tremendous rates of gain, and you will just kind of like bomb the soil with carbon. It's a quick start. It's like a remarkable start. This is actually a picture of a farm I worked with in North Carolina, where we had burned out tobacco land, really tough land. We planted this 8-way cocktail cover crop, and you can see the cattle, we're stripping it out. You can't see it, but to the left of the cattle is a wire. And we just give them a little strip and they just go crazy on it. So yeah, here's a video of them moving into the new cover. You see they were running. They're so excited to get in there and see the grass is way over, the cover crop is way over their head. And these guys are a little confused. They got to figure out how to get around the fence. But but they get in there and they just go crazy. You can see now they're moving into it. It's over their heads and they just chomp, 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 chomp. And remarkable. And again, this is on land where the carbon had been stripped, but we're rapidly putting this carbon back in, both because of the roots of these plants and because we're trampling a whole bunch of it as they graze. So yeah, that's about them. But you can see, we stand out for a little bit, you can see that's that cover crop and how we grazed it from a distance. So the electric fence is right to the left, but you can see they're just like, they just, and the result to the soil was just stunning, how quickly that soil organic matter was kind of revived. And the whole biological, the real key is the microbes and the fungi and everything else was kind of restored with very rapidly with this kind of cover crop shock. So that's one way to transition some of this land that's been, corn growing on it for 25 years is pretty tough on a piece of land because it pulls the carbon out and doesn't put much back in terms of organic matter. The way it's grown today, it's all chemical fertilizers. Not much manure gets put back. But the reality is that how you manage a cattle will actually create grass. So this is a side-by-side picture. The one on the left is it's actually in West Brookfield, and the farmer in the picture, who I won't name, puts his cattle out in the springtime, and then they just stay out there. I mean, he didn't put them out there. They're there when it's still snow on the ground. And as the snow melts and the grass begins to grow, they're there. And they're there all summer long, all summer long. So every time a plant grows, they come over and nip it off every time. So essentially, it's like a golf course. There's very shallow roots, not much above the ground because they just constantly go back in. And this is basically how cattle are managed in a whole big swaths of the West. People have a range in the BLM land that they lease, and they just turn the cattle out. And the cattle, of course, are good judges of what's tasty and what's healthy, so they go and eat it. But then they're kind of parked there, and as soon as the plants grow, they eat it again. On the right, you have an instance of adaptive multipatter grazing, and you can see in this picture, this is fall in the right, and there's still tons to eat. But these cattle haven't sat on this piece of ground all summer long. They've had a bite, and then they moved somewhere else on the farm, and they came back and had another bite, and then moved off. So actually, the management will create grass, and really, it's all about allowing the plant and the soil to rest and rejuvenate without the cattle returning and taking another bite before the grass has had a chance to grow. And that's kind of what happened with the buffalo naturally. There were so many of them that as they moved through, there was nothing to eat. They had to move. So we try to create that with the use of electric fence. But that's the concept. It will actually create lots of grass. And it's absolutely true that grazing correctly results in higher fertility, more grass, and water retention, all of the above. So these are two side-by-side pictures. The picture on the right, South Africa, is one of my mentors, Ian Mitchell Innes, has a ranch there. And he learned how to do this kind of adaptive multipatter grazing a number of years ago. He's a great teacher and teaches people how to do it. And you can see his ranch is to the right of the fence, and the neighbor's ranch is to the left of the fence. So basically, in the same environment, same rain, same sun, same everything. One is green and got some depth of sward, and the one on the left is got nothing. In the picture on the left, this is actually the farm that belonged to East Quabbin Land Trust, or belongs to East Quabbin Land Trust, that I farmed for quite a while. And I was touring some people through it in early July, and the grass on my side was so tall. The reason we didn't graze until July was because of the bobolings. So they were in a program where they wanted to wait until the bobolings had fledged before the grass was either grazed or mowed. So we actually had to climb up in the birding platform, which is a 12-foot high platform on the land trust that you can climb up there so you can look down at the birds and the bobolinks and everything. And as I looked down, I looked out and I thought, oh my God. So you see there's a stone wall in the picture. So the grass that I've been managing was on closest to us. And on the other side of the stone wall, my neighbor who's what he does is makes hay. He has no cattle. He just has equipment and makes hay. And I could look at that and I think, oh my God, look at the difference in the color and the height. So I went back that afternoon or the next day with my boy, who at the time was 4 feet tall, and I had him stand on my side of the fence, on my side of the stone wall. The grass is up around his head. And I took him over to Mark's land, the other side of the wall, and you can see the grass doesn't even come up to his waist. You can see there's the stone wall in the back of the picture on the right. So, you're looking at the same soil, the same rain, the same sun, just different management. And what I say is that when I see grass that's 4 feet tall, I know my roots are 4 foot deep. And I also know that my grass wouldn't grow 4 feet tall unless it had an ample amount of carbon in the soil, and the soil food web was functioning and feeding these plants. They couldn't grow to be 4 feet tall unless they had life under the soil. This is one of the things, there's a whole lot of people trying to quantify carbon, and it's very hard because carbon is very volatile, as I said, and you can measure the carbon in the soil here today, come back tomorrow, and it would be different because the carbon moves. Carbon wants to move. But there are companies that reward carbon already, carbon credits like Indigo. They pay the farmers based on the process that they use, not the outcome. So they don't even try to measure the carbon. They just say, okay, if you use a no-till seeder instead of a plow, you're saving carbon. Here's some money. I think that, you know, to some extent, I'd like to see an outcome verification, like let's measure the carbon. But the question is, how do you measure it? Where do you measure it? Do you measure it at 6 inches under the soil? Do you measure it at 4 feet? And again, I go back to the fact that just using a proxy, if I have grass that's 4 feet tall, I know I have grass that's roots that are 4 feet deep, and I know I have carbon because I couldn't have that without the carbon. So anyway, long story short, that this is like two different management systems side by side, which is fascinating. And you can see that stick in Isaac's hand. It's what they call a grazing stick, and like the NRCS and Extension passes them out. But it's a stick where you can actually, it has like a little measuring thing on the bottom, so you can measure the height of the grass. But then one of the intriguing things it has on the side of the stick is a little grid with a bunch of dots. And the idea is that you can take the stick and you can slide it into the grass flat on the ground and look down on the stick, and you can see the number of dots. And then there's a little scale on the side of the stick that tells you, you do your multiplication of how many dots will tell you the density of the grass. And then you can estimate the amounts of dry matter per acre inch by doing that calculation. So anyway, after we took this picture, we took the grazing stick and went back on my side and we stuck the stick flat on the ground. And as you can see in the picture, we can't even see the stick, let alone any dots. So essentially what we find is you can increase the biomass. In the slide, I say threefold. The current research by Richard Teague and the guys out west is that you can actually increase the biomass per acre 5 to 6-fold by grazing correctly. So think of the economic impact of that. If you had a piece of land, say you're renting your land for $25 an acre and you have so much grass. Now, what happens if you have 6 times that much grass? What is your acre costing you? It's less than $5 an acre because you have more biomass per acre. But anyway, that really is representative of the carbon and the whole soil food web, the microbes, the bacteria, the fungi, and the fact that that whole underground thing is functioning is indicated by the grass and the density of the grass. Net result is you have more grass for your cattle to eat. So this was just a picture. I didn't link this video because it's like about a 6-minute video. We probably could have had time to watch it, but if you go to our website, you can see this video. But anyway, what it is a simple perk test. So this guy Stan Bowles, he's in South Dakota, but he decided to test the 3 different kind of management scenarios in his region. So the first test he did is a farmer had decided to plant corn, so in this rangeland. So what they've done is they sprayed glyphosate, Roundup, to kill the grass, and then they used the best practice, which is no-till seeding, to plant the corn. So when Stan went over and did a perk test on that piece of land, and basically for the perk test, he just takes his pipe, drives it into the ground, pours in a quart of water, and then measures how long it takes to percolate. So on the corn land, it took 30 minutes to percolate, 30 minutes to go into the ground. So, one of the things I tell people is I could stop the flooding in the Mississippi. I could cure the drought in the West. and I could cure the human obesity. You just have to give me the 3 states of Illinois, Iowa, and Indiana, the old prairie, and a big herd of cattle. Because those 3 states are 98% corn and soy. So if you have a state that's all corn and soy, and you cannot percolate the water into that ground for 30 minutes, where do you think it goes? It goes down to the river, and the river's the Mississippi, and then you get flooding. So it's really a scary thing when you think about it, that corn land won't perk. Anyway, so Stan moves over to the extensively grazed land where you put the cattle out for all summer in one paddock. And the results were dramatically better. 7 minutes to percolate. Then he moves over to the area where we're doing this adaptive multi-paddock grazing, and it only takes 10 seconds to percolate. So if you want to capture the water that's raining and get it back into the soil and into your aquifer, adaptive multi-paddock grazing is the way to do it. And again, as because of the porosity of the soil, because of this grazing methodology, linked with the soil life and the carbon in the ground, means that the water that does penetrate the soil will be captured. It'll be absorbed. Carbon will hold 7 times its weight in water. And this is what I'm saying about the the science of the soil and what's going on is just beginning to catch up. It was in late 90s that this woman discovered glomalin. And glomalin, Sarah Wright is the one that discovered it. It's a waxy substance that creates the aggregates in the soil. Nobody knew it existed until the 1990s. And it's this remarkable thing that makes the carbon stable in a little waxy package in the soil, deep within the soil. But all of that carbon that's in the soil in a healthy adaptive multi-paddock grazed grassland means that the water that penetrates gets absorbed, and then it gets slow released, probably back to, we didn't have a picture of a water cycle, but probably when you were in biology in grade school or high school at the latest, you had this water cycle. So you had water in the ground, you had transpiration and plants, and then back around. And we've just totally broken that cycle with our agricultural practices. So anyway, go to the website. You can see that video. It's pretty remarkable. Just a second. I gotta close my door. Sorry about that. The dog didn't understand. So anyway, this photo is another kind of indicator of the carbon. And what's fascinating, this is a photo that Christine Jones let us use. So she tells the story. These are 2 soil cars of adjacent farms, and the adjacent farms were one farm. So the father passed away. He left half the farm to each son. So one son continued with conventional management, growing the things he growed, conventional fertilizers, on and on. The other son started rotationally grazing, and this is over 10 years, and you can see the difference in the topsoil created. It's about 20 inches of topsoil on the left, created in 10 years. So there's many people that tell you cannot build topsoil and you cannot build it quickly. It'll take eons to recreate. And it's just not true. And it can happen very rapidly in the presence of a ruminant and photosynthesis. And this is, again, there's kind of a lot of instances that are indicative of this fact that the carbon can build a healthy topsoil very quickly. My experience, it takes about 3 years. So if you took over an old cornfield that's been in corn for 25 years, in spite of the poisons that have been sprayed and that kind of thing, in 3 years' time, you can get a healthy, vibrant soil food web going again and really strong grass growing. So it's fairly quick in terms of time. So anyway, back to talking a little bit about cattle, because I just that's what I talk about. But to give you an idea how this works in our region at scale, in the opportunity to put down carbon, there's about 433,000 calves born in our region in the what we call the Northeast. So and these are beef calves, not dairy calves. So our region that we concentrate on is the Northeast, as described by the USDA. So there's like a Northeast Pasture Consortium, and includes New England, New York, Pennsylvania, Delaware, New Jersey, Maryland, and West Virginia. So in that region, there's over 433,000 calves born. The vast majority of those calves go west to the feedlots and come back as a piece of meat. It's a very, very small proportion that are kept in the Northeast and finished and harvested. The other thing to note is that the average herd size of cow-calf herds in the country is 40 head. In the Northeast, they tend to be a little bit smaller, so you have a herd of 20 to 40 head is very typical. And once you think about this, you've seen them everywhere. Everywhere you drive, you see these little herds. And one of the things that's interesting about it is that the calves look like this. If you have the right kind of cows, and we'll talk about the right kind of cows, and you can see this is a mix. There's all different genetics in there, but the cow is very functional on grass, and the calves are, wonderful calves for grass. One of the things to point out in this picture is I won't go there. We spent a lot of time talking about the right kind of cattle. We'll talk about it a little bit. But the idea is that you have all these herds, small herds, and then you take the calves, instead of sending them west to the feedlots, if we took them to a grass finishing farm, we think that's the idea. So to get off on that tangent a little bit about the right kind of cow, this is a picture that where I worked at Old Servants Village, there's all these livestock paintings, and I always thought to myself, man, that artist was drunk or something. An animal like that with a big body and a little tiny head and real fine legs. I mean, that's crazy, but you see them all different colors, all different breeds and everything. So anyway, for function on grass, that's the kind of animal. Well, anyway, we found some. So we found this cow in Massachusetts, and that's the ideal animal for grass. So not very tall, very deep, wide, and they just get fat looking at grass. So anyway, that's the ideal type. And like I said, we could talk hours about this, but that's just to show people that, and this is a big issue, particularly in cattle, and particularly in dairy cattle. So there's many people that are trying to go to 100% grass dairy. It's very hard to do because most of the genetics in the dairy breeds have been selected for concentrate feeding on a concrete pad. And if you turn that cow out into a field of grass, they'll kind of look at you like, what am I supposed to do with this? I mean, they don't have the physical conformation to function on grass. It's been stripped away, partly because of artificial insemination, and everybody has the same Holstein book, and the top bulls that produce the most gray milk and not very much butter fat. So it's become very concentrated, but the cattle just don't function on grass. So you got to pick the right cattle to do this whole carbon drawdown. You got to have the right cattle, or you will not succeed. So anyway, everybody's interested in that. We can talk a lot more about that. But the bull on the left is definitely a phenomenal grass bull. The cow in the background of the right-hand picture is kind of a typical cow. She's Angus Sim, but you can see all her bones. You can see her kind of her ribs. She's not a bad cow, but she's not a real functional cow for grass. But anyway, what we did is we took that cow in the background and we bred it to this bull, and we got the calf in the foreground. So we have a phenomenal calf for function on grass out of that kind of so-so mom by pairing it to a phenomenal bull. And the other thing we get, this goes to the economics, but when you breed two unrelated animals, you get something called hybrid vigor, 15-20% increase in productivity. So that's what that calf is representing, is that hybrid vigor. Anyway, all of these things would be a long talk in their own right. But what we try and do at Big Picture Beef is we have all these small cow-calf farms. They're all over the place. And we would love to influence the genetics on all these little cow-calf farms to be beautiful calves like the one I showed you a picture of. And we're working on that. But then what we do is we aggregate those calves to a large finishing farm where then the skilled grazer can graze and fatten the cattle. Get them, when we refer to finishing in a grass system, it's fattening them, but fattening them on a high energy grass. So this is our game. And so we have, like, for example, we have one finishing farm in Vermont that's got 1,800 contiguous acres of grass, and they graze about 650 head on that farm. So a whole bunch of calves from a bunch of small farms to this one big farm where they move it and move the cattle in a big group. So here's a picture of that farm. A herd of 650 head in Vermont moving to new grass. So a lot of people say, well, how do you get them to move? Just get out of their way. They know how to do it, and they know they're going to good new grass, so they're ready. They're moving. And the other challenge with bovines is they're curious. I always say curiosity killed the cow. So you see these couple that want to look at the camera and see what's going on. Like, what are you doing? but you see how that is. So now if you look at the again, going back to economics, you look at the economics of moving a herd of 650 head. Take one or two people make that move. And so their labor now divides into a bunch of animal units. The challenge with finishing on the little cow-calf farm is if you have just 20 head, you can't make a living on 20 head. You can't make a living on 40 head. So you have another job. You sell tractors or you teach school or you do something other than take care of the cattle. So you can't be there all day to make your moves and finish efficiently. You can finish them, but not efficiently. So anyway, they just keep coming. Some of them, of course, get lost. You have to figure it out. But anyway, that's a good picture of moving a big herd. This actually on the right is a picture of that farmer, Mark and Cheryl. And some of the statistics that they what they've done on their farm over the years. They've converted all this corn land to perennial pasture, hay land to perennial pasture, and increase their organic matter phenomenally, which is carbon. So this is kind of the system that we are interested in perpetuating, and it has benefits all the way through. The cow-calf farmer get a little bit better. These folks make a little bit more, and the cattle stay in the region, get harvested in the region, and go to the markets in the region.
Ridge, there's a question about which farm that was. I think Mark's farm.
Meeting place pasture, Mark Cesario.
Thank you.
Cornwall, Vermont. So we're talking about the economics and a little bit, and the carbon, and talking about the different circumstances of cows and calves and finishing. And this is something that I just wanted to waltz through here fairly quickly, but part of the economics of the cow calf operation is the hay, and the cost of the hay. It is what will keep you from making any money with cows and calves. Absolutely. So, you know, I had this herd, and I had about I don't know what, we had about 40 head, and I was buying hay to feed them. I never got bit by the tractor bug, so I don't own a tractor. I don't own a baler. I don't make hay. I buy it. So I know exactly what it costs me, which a lot of people don't. But um, so what I would do is, my neighbor had a tractor, and the neighbor that makes hay has a tractor. So I would go borrow his tractor. I'd give him some new tires every once in a while or something. I got myself a bale grabber. So I would feed all my hay to my cows in October. So I would go get my white wrapped bales in October, and I put them all over the farm. So if you did a Google Earth of my farm, it would look like marshmallows placed all over the place. Then I would put an electric fence, and I'd stick the fence post into the next row of bales to keep the cows from going into those. And I could just walk out there with my jackknife, or in the wintertime, walk out there with snowshoes and my jackknife, open up a new bale, and feed my cow pretty effortlessly. No machines, no starting diesel tractors in the wintertime or anything like that. And I could, you know, create a new area around each bale. But what it got my attention was that every time I opened up a bale that I'd spent $50 on, the cows would go over and they'd eat whatever was on the ground around the bale before they ate the bale. I'm like, wait a second, cows? I paid good money for that. Go eat that. They're like, no, we're going to eat this. So anyway, that got my attention. So the next year, I saved about 2 acres of grass. I quit grazing it in July, and I said to Ben, the kid that worked for me, I said that, you know, we'll just graze that in the wintertime, see what happens. Well, that winter, it was actually 2010, I think. There was an article in Time magazine that featured me and Elliot Coleman from Maine and my cattle. And so they wanted to send a photographer. It was January 15th. They want to send a photographer to Hardwick. It's freezing. We have 8 inches of snow on the ground. So I said to Ben, I said, let's put the cows out in that paddock we saved, see what happens. So the whole time you can see me in the pictures, I'm freezing, I'm shaking, and the cows are behind me with their heads down through the 8 inches of grass, nibbling away, eating the grass under the snow. So we got done with a photo shoot, and I said to Ben, look, let's put the cattle back in the protected area with the baleage, but leave the gate open, see what they do. Well, they went and finished that 2 acres before they went back to my baleage I paid $50 for. I'm like, they're trying to tell you something, Rich. So the next year I got a SARE grant, and what I did was I kept 20 acres. So in other words, I grazed until like the first week in July. Then I quit grazing that 20 acres. I took a forage sample of that grass and sent it to Cornell. And then I took the cattle elsewhere, one of my other farms. I brought them back in December to start grazing that stockpiled forage. And I kept them on that 20 acres from December, January, and February. So I sent forage samples of those in those months to Cornell as well. So this is what it looked like in the wintertime. You can see I didn't just let them go into the 20 acres. I still put in a fence and let them have a little bit. I never back fenced it because once they ate it. But this is what it looked like. You know, it looked like dry stuff. But and actually it was a SARE grant. So all the there's photographs and there's narrative and all that stuff. It's on the web. You go to our website, there's a link, or if you just search winter grazing New England, you'll go to it. But and there's pictures in that whole study of manure. So the reason I put the picture of the manure in is that is a perfect cow patty. That's indicative of functioning rumen. That's how your cow patty should look. It should be round. It should be, if you kicked it, it would look like custody, and it would have a little dimple in the middle. That's a perfect cow patty. And that's what was coming from these cows that were eating my stockpile. So I was confident that they were happy and healthy. And when we vetted them when we preg checked them in March, and the vet said to me, he said, Rich, what, these cattle are beautiful, great condition. What have you been feeding them? I said, that over there. He said, you couldn't, no way. I said, yeah, that's what we're feeding them. So it was pretty interesting. But anyway, so we got all this data from the, the forage samples. So the chart on the left, you can see we have 4 points in time. We had July, December, January, February. And you can see that we measured all the things one typically measures in forage, relative feed value, total digestible nutrients, all those kinds of things. And you can see the values decline. And it was a little bit erratic. I went to my advisor at UMass, Stephen Hebert, and I said, Stephen, it's pretty erratic. He said, oh, well, you probably should have taken six samples at each sample site and then averaged them. Like, okay. Well, this is what we got. So he put them on this graph, and the values decline over the winter. So then I went to him. I said, okay, Stephen, we got this graph with different points, but could we plot on the same graph a bale of baleage and a bale of dry hay? So he took a sample from a dry grass hay bale at UMass, and we took some forage samples from the forage I was buying from a farmer, and he plotted them on the same graph. And you can see that the feed values of the stored feed were less than my grass in the field. That's before you even start talking about the cost of making that hay, putting it away, bringing it back with the tractor and feeding it out. So it's a huge, huge paradigm shift to get farmers to think about this. Everybody says, oh, I have snow where I live. It's like, yeah, I know, but and you may not be able to do it 365 days a year, but everybody typically spends 180 days a year feeding hay, and most farmers are out in June. It's hard to have them come to a meeting because they're out there mowing their field. I'm like, park the tractor and come to the meeting and listen to what I have to say. Let the cows go eat it. Don't mow it. Don't put it away. Anyway, it's a tough sell, but you go read that study if you're interested in, and there is a narrative about the cost parameters and why it's really a possibility to do this and to do this in the Northeast.
Can I ask you a quick question, Rich?
Sure.
So that field that you hadn't mowed at all, that was not done first cutting or anything, that was just left standing all season and then into the winter?
Yeah.
Okay, thank you.
Yeah. No, and that's the thing that a lot of, because I had leased land, I had different farms. I had one 40-acre farm that used to be in my rotation. And one year I did my grazing plan, and I decided I wouldn't bring the cows to that farm until September. So I have 40 head of cattle, 40 acres. I wouldn't even arrive until September. So just let the grass grow, let the grass grow. Well, the neighboring dairy farmer was going ballistic. He kept calling the homeowners and saying, you want me to come cut that hay? You're wasting that hay. You want me to come cut it? And the homeowner would call me up. I said, no, don't you dare. You're gonna leave it alone. And this farmer called him twice. And I said, no, that's my plan. So when we went over there, of course, there's all this dry grass, but underneath is green grass. Now you go back and look at the ruminant's needs, the need of the rumen, it needs dry and green. It can't make a living on just green. And the cows were perfectly happy going into that 40 acres. They did remarkably well. And again, the key was fencing them so that they trampled what they didn't eat. So we learned that we had to make these long, narrow paddocks. You give them a big square paddock, they go and select, and they would take what they wanted, and you wouldn't get any trampled to speak of. But as we made the paddocks narrower, where they had to walk to eat, we get the grass down on the ground. So there really was no weed issue. A lot of people say, oh, the weeds are going to go crazy. Well, no, you just trample them. And in reality, better grass comes, out of that scenario. But Yeah, I'll tell a quick story because I got a few minutes because, well, not that long, right? We got about 15 minutes. I'll make it quick. So this is the story that I tell people when they say can't do it in my environment. So I have a friend, Glenn Barlow, who lives in Gillette, Wyoming, and he went to a ranching for profit class, and Dave put up on the screen, he had two farms side by side, and they were equipped the same way, the same amount of cattle, the same everything. And this is going to be a 10-year experience to see experiment to see which farm made more money. So one farmer was a great farmer. He did everything right. He always took care of his tractors. He mowed his hay, put it in the barn, he fed the animals. The other farmer went to Hawaii for 10 years. So which farm made more money? The farm with no inputs made more money because the cows that couldn't have a calf died. The ones that did kept having calves. There were no inputs. There was no labor. There was no nothing. So Glenn goes home to Gillette, Wyoming, where he's got 500 mother cows, and his brain is on fire. He's like, what do I do with this? You know, so because he was feeding supplements in the wintertime, starting tractors in the wintertime, having the calves in the snow, on and on, going out, taking care of the calves. So he just changed everything. So that his calves now are born in May when the wild ruminants having their young, and he doesn't feed anything. So I went to visit him, and we're going from the airport and we're driving down the highway toward his ranch, and there's these huge wooden barriers on the side of the road. And I said, Glenn, what in the hell are those? He goes, oh, those are for the snow. Those are keep the snow off the road. I said, well, you get a lot of snow then? He goes, yeah, 25 feet. I'm like, 25 feet? And I said, it probably gets cold. He goes, yeah, 25 below. And I'm like, Glenn, tell me how this works. Your cows live outside. They have to go find something to eat and bring back a cow. He said, yep, that's how it works. He said, there's always a wind blowing. There's always some sage. There's something to keep them alive. Because I breed them so the calf comes in May, they have a minimum of a month and a half of green grass to put all the minerals back in shape, have a successful pregnancy. He said, of course, when I first started, a bunch of the cows sorted out of the program, didn't come back with a calf. They had to be harvested. But he said, now, instead of starting trucks and tractors all winter long, I go sit in front of my fire and read a magazine, watch a movie, whatever. But it's a huge paradigm shift. And it's hard for everybody because we have this human thing that we should be taking care of the animals, when in reality, animals can take care of themselves, given us half a shot. You know, I mean, that's one of my big things about the wintertime. Everybody says, you leave your cattle outside in the wintertime? I'm going, yeah, of course I do, because that's a bovine thing. It's not a human thing. So the bovine has got this compost pile going. It's got this back fat over it. The cow would prefer to sit down and get 8 inches of snow on it, get up, shake it off. Now, you as a human go and do that, you're going to die because you're not a cow. You don't have a rumen. You don't have a compost pile. And you don't have that fat. Anyway, long story short, and let me zip through the rest of these. This is, I mean, there's so many benefits that are attributed to grazing correctly, but carbon is the driver. Again, you know, this is farmers have to, eaters have to make a choice. I love this quote from Wendell Berry: eating is an agricultural act because people choose which modality they want when they buy a piece of meat. Most were buying the left because they don't know about the right, but that's changing. And then I just end with this quote. I love this quote because this quote is from the 1930s. Henry Wallace, who was the Secretary of Agriculture. And this is what he said. He said, grass will act as the great balance wheel and stabilizer to prevent gluts of other crops, to save soil from destruction, to build up a reserve of nutrients and moisture in the soil, ready for any future emergency, to create a more prosperous livestock industry, and finally, to contribute to the health of our people through better nutrition. This is in 1935. He knew this, and we're just catching up. Anyway, does anybody have questions at this point? I know we don't have a whole lot of people on here, but are there any questions anybody's got?
There's one comment from Julie. I don't know if you want to speak up, Julie, but I'll just read your comment. She said, that's so cool and so logical. The herders I work with in Niger who are also farming always leave their residues for their beloved cows.
They
Oh,
always
there you are, Julie.
Yeah, hi, Ridge.
Hi.
And we spoke a long time ago on the phone about regenerative agriculture last year. I work at Dartmouth College, but yeah, this is all really just such logical stuff, and it's so
does.
surprising how illogical our agricultural system has, you know, gotten itself into these path dependencies that we don't need to be in. So thank you so much for all your work.
Yeah. Well, you know, it is so logical once you see it, but see, it's not it's very hard to boil into a soundbite for people to understand. That's the problem. It's very complex and there's a whole lot of pieces to it. But once people see it, that's like, oh my God. But then it's a challenge of, you know, finding the product. It's one of the reasons we're in the meat business is so people can find the product. But you know, because a lot of people they want to buy grass-fed beef, and they go to the grocery store, and 80 to 90% of that meat is from Australia and Uruguay. And until quite recently, and it's still the case, that if you bring a container load of grass-fed beef from Uruguay to the Port of Boston, and you bring it to Sutton, Mass, and you grind it up and package it, you can write right on it, product to USA. So it's very confusing for the customer to say, oh, grass-fed beef, product USA, great, we'll buy it. But it's outrageous. But
Rich, can I ask you, is there a map of where the farms are that are doing the finishing in Massachusetts, Vermont area?
no, not a map, I could tell you. I mean, there's only a handful, you know,
Great.
and there's some in New York as well. And you know, we're
Yeah,
active.
where are
Well, the Marks is in Cornwall, the Snug Valley's in Hardwick, Vermont. And then there's a couple over in Eastern New York, Central New York, or
Okay.
what the other ones are. And you know, we're actively recruiting, looking for former dairy farmers to become grazers, to become finishers, because most dairy farmers, conventional dairy farmers, are at the end of the rope. You know, they commit suicide, or they're, you know, they just don't have a financial viability. I have one farmer in New York State. Well, just to say, back when I worked at Old Service Village, I also ran a modern dairy farm and herdsman, and we milked 125 head. This is like a long time ago, 40 years ago. And we were making $14 a hundredweight for our milk. So I was talking to my friend in New York, who's been third generation dairy. They own the farm, they do everything right, but they're conventional dairy, third generation. He said, we're getting ready to throw in the towel. And I said, I'm not surprised. And I told him that we had been making $14 a hundredweight. And he said, yeah, we're making $15 a hundredweight, 40 years later. I mean, it's just insanity. But the dairy farmers amassed a large plot of land, a couple thousand acres between owned land and adjacent land. So, and if they are looking for a paradigm shift, we can show them how to plant a cover crop and immediately start getting gains equivalent to feedlot gains, over 3 pounds a day on a cover crop. And it will stimulate the microbial activity, put everything back in order, and you can use a temporary fence. So it's an option for people, but it's something that, and one of the reasons we're excited about the former dairy farmers is that they know cattle. They know if a cow has got a full rumen or not. They know how to handle cattle. I mean, they got some things to learn, like how to fence and how to do cover crop, that kind of thing. But I keep saying it's an incredible opportunity where we have these dairy farmers that are going belly up. And this one in New York, I could probably take a rock and throw it into Manhattan. You know, I mean, we got the markets of the world, and we got the resources. How come we can't get from here to there? And one of the things that's most amazing in the Northeast is the fact that we have, I mean, our huge unfair advantage is rain and dairy quality soils. So, you know, I spent an evening with Bill Nyman of Nyman Ranch in New York just a year or two ago, and we spent about 4 hours together. At the end of the 4 hours, he looked over at me and he said, Rich, he said, you know, for a Yankee, you know an awful lot about cattle. I said, well, I'll take that as a compliment. He said, but Rich, you can't grow cattle out here in the East with all your trees and stone walls. I said, well, Bill, how many acres does it take you to support a bovine in your environment in California? He goes, yeah, 15 or 20. I said, Bill, it takes me 1 or 2. And I said, here's the kicker, Bill. Where's the market? He says, you got me. But all that's true. But how to go from here to there is the challenge.
I've got another question, but if someone else does, I don't want to dominate.
No, go ahead.
I'm curious about the carbon programs that are coming out of the Biden administration that are looking at, like the indigo ags and the folks who are trying to sequester carbon through the soil practices. Do you see that coming into your purview to try to maybe support your work in some way?
It's possible. Right at the moment, I think it's a lot of Wall Street malarkey. No, I mean, Wall Street has inserted herself in that whole equation and wants to, pay the farmer a little bit, but then take the lion's share and put it aside. And the reality is, if we were to get a little bit of bump out of the carbon, that would be fantastic. And I don't see how it's going to be work and be administrated. The problem with the outcome verification is carbon is so volatile that, even with the soil testing and which soil profile, where do you test, and how do you measure? I mean, indigo, a lot of those people are going on process verification. So you simply did not use a moldboard plow, you used a no-till seeder, you saved carbon, so that kind of thing. That's fine. That's an encouragement. But the reality is, and again, as I said, if you have grass that's 4 feet tall, you got carbon, but more importantly, you have the economic resource of 4 or 5 times the biomass per acre, which is really the economic. At the end of the day, you want healthy and more grass. The researcher Richard Teague, who's doing the research on adaptive multipatter grazing, he's out of Texas A&M, and they just got funded by McDonald's, 2 years ago now, to do research on adaptive multipattern grazing. So I was chatting with him. I said, Richard, you got to hook me up with McDonald's. I want to sell to McDonald's. I said, everybody talks about food deserts, and who is in every food desert in the country putting protein in poor people's mouths? It's McDonald's. And so I'm like, hook me up.
Yeah.
Oh, and he said, but Rich, it's price. I said, I know, Richard, but if I can get 3 times the biomass per acre, we can begin to compete on price. And he said, Rich, you're wrong. And I said, what do you mean? He said, well, the research shows 5 to 6 times the biomass per acre. So it's a stunning potential, to take all that corn land, and particularly the corn land is, the land that will respond much more rapidly to this kind of grazing. I converted a dairy farmer in town, next town over. He'd been a dairy farmer for 25 years. His wife had died. He had a new girlfriend. He was looking for an alternative. The friend brought him over, and I toured him around and gave him a bunch of books on a Friday. And a Monday, he called me. He said, I read all the books. And I said, great, I got more. And he said, no, I visited your farms in Vermont over the weekend. I sold my dairy herd. They're leaving on Wednesday. I bought a fence post founder. And now I'm going to be a grass farmer. I'm like, oh my God, just like that. And I said to him, I said, Jim, now make sure and plant down your corn land to perennial. He said, oh, I was going to keep growing corn and sell it to a neighbor. I said, no, close your eyes, plant it down to perennial. So about 3 or 4 years later, I ran into him at the post office or somewhere. And he said, Ridge, he said, that corn land is growing my best grass. I said, duh, your best grass growing your best grass? Really? That's a shocker. But that's the potential of that, land that's been in crops, because it tends to be the flatter, more fertile land. The opportunities are just, it's just crazy making. And particularly because all that land, like if you go down the Connecticut River Valley, all that land, all that corn land that's right on the river, it floods into the river every year. You put that down into cover crops and perennials, you would, it's just remarkable potential.
I'm curious about the breeds, if you're willing to speak about that a little. It looks like a lot of Angus, Hereford, Devon.
You got it. So what we found, my trail started with, I discovered grass-fed beef, and I figured we'll try it. And I went to one of my producers and said, let's just kill some, grow some animals and kill them. And it was all over the place. The quality, the taste and tenderness and everything. So then I hired a guy, and we started going around with an ultrasound machine and a linear measurement tool. So we can actually physically measure the animals. And with the ultrasound machine, you can see the intermuscular fat. And what we found is that to really succeed, you need the right kind of animal, which is a moderately tall animal, but you need one of the British breeds. Because if you want tenderness and taste, you always go back to the British breeds. So the Continental breeds that were imported in the 1960s to make the cattle bigger for the feedlot, the Limousin, the Charolais, the Simmental, all those big, basically Continental draft breeds really clobber the quality of the meat, and they tend to be big bone and tough compared to the British breeds. So we always go back to the British breeds, but it's of course a subset of the British breeds. But yeah, the ones you see, the Hereford, Angus, Devon, those are the ones that, Red Angus, all of those are the ones that you want to start with. And then, select within those breeds the right kind for grass, which are the moderate animals.
Excellent, thank you. Any other questions from folks? Oh, doesn't look like it. Great.
Somebody unmuted. Did they just pop? I don't know. Looks like somebody unmuted.
Looks like another thank you. We learned so much. Great job. Excellent. Yeah, me too. I'm inspired by your work and learned a lot, and I can certainly see your passion for this. So I wish you all the good luck as you keep going.
Yeah.
I'm going to just paste a couple of links in the chat just to make sure folks remember we're having an auction and thank our sponsors. And there's also an evaluation for this workshop, so we can give us some feedback if there's anything that you really enjoyed that we can do again, or ways that we can improve. We'd appreciate your help letting us know. So with that, we'll let you go, and thanks so much, Ridge.
Sure thing. Thank you all.
All right, bye-bye.
Thanks for the opportunity, really.
Yeah, thank you. Hopefully we'll talk again.
Yep, sounds good. We'll see you.
Bye-bye.